Hey everyone, welcome back to the channel Code with AKJ. Today is day 30 of solving Geeks for Geeks problem of the day. Today's question is alternate positive and negative numbers. So the question says given an unsorted array ARR containing both positive and negative numbers, your task is to create an array of alternate positive and numbers without changing the relative order of positive and negative numbers. Array should start with a positive number and 0 should be considered a positive element. So given example here, the positive elements are 9, 4, 5, 0, 2 and negative elements are -2, -1, 5 and 3. So as we need to maintain the relative order of positive and negative numbers, here we consider two different arrays, positive elements and negative elements, and we'll pick each element and we'll store them. So if any of the positive and negative numbers computed from any of the array, we'll continue with the remaining signed integers and we'll fill up the array. So given from this explanation, we can easily find out the brute force approach. We need to maintain two different arrays containing positive and negative elements, and we'll take the help of indices and we'll store the result array by picking each and every element in their relative order. So here the brute force approach takes time complexity of O of n, as we need to iterate over an array once to check and pick all the negative and positive elements, and our space complexity would be O of n, as we need two extra auxiliary space. So let's try to understand this approach. So here's the visual representation of the brute force approach. Here I've taken an array. I've split these elements into two different arrays, negative and positive elements, and with the help of indices we'll just store these elements by picking each element from these two arrays and storing it in result variable. So let's try to code this approach and we'll see whether it gets accepted or not. Before moving on to the code, the time complexity here would be O of n and space complexity would be O of n. So this is a code for the brute force approach we have discussed through this example. Here I have taken the size of an array. I have taken two extra spaces, positive and negative. I have iterated over the original array and I have split all the negative and positive variables inside two different arrays. I have taken three indices, I and j. I will run over negative array and j will run over positive array, and k will run over the original array, and we'll run a loop until or unless the size of each of the array becomes negative. So we'll store the original array in place by placing the positive and negative elements from these two extra auxiliary arrays. So if any of the array becomes empty, so in this case we'll run a loop and fill out the remaining positive elements. In this case, if negative array becomes empty, and if next to array becomes negative, we'll fill out the remaining negative elements. So in this way we'll complete this problem statement. So let's compile and run. So let's submit. As you can see, this problem got solved successfully and we have completed this problem in our expected time complexity and space complexity, which is O of n and O of n as well. So there's a way to still optimize this approach and complete this problem in O of 1 space complexity without using any extra space. And before moving on to that, I would like you to please give it a like, share with your friends and subscribe to this channel. So to optimize it further, we'll use the index out of place, which will help us to track the element which is out of place inside this array. So initially, since the positive number should come at first and then followed by a negative number, we can observe from this way of arrangement is that positive elements should be presented even indices and negative elements should be presented odd indices, which is 0 to 4 and 1, 3, 5. So let's dry run this approach and later on we'll move on to the code. So initially we'll check the element at index I is equals to 0. Since it's a positive element and it is placed at index 0, which is even, we'll continue with our process. So coming to the index 1, the value here is 4, which is positive, and since it's placed at odd index, so it's not a optimal place of placing this positive element inside an array. So we'll mark this out of place index to position 1. So again, in our further process, we need to find a negative element. So to swap these two elements and put it in its place. So coming to the next index, when I becomes equals to 2, which is a negative number, and it is placed in index even number, so this is not a right place to be placed. So we'll swap this negative element with this positive element by right rotating. So in this way we'll rotate these two elements and make these two elements in its place. And further, after swapping this, we'll update the out of place by using this condition where we'll compare the current index with its previous out of place index. So if it is greater than 2, we'll update the out of place value, or else we'll remain this value as -1. So in this way, by processing all these indices and right rotating these elements, or by swapping these elements, we can place these positive and negative index in their right order by maintaining its relative order. So in this way, without using any auxiliary space, by using few pointers and right rotating, we can place all these elements in its actual place. So here the time complexity would be O of n, as we are iterating over the array once, and since we are not using any auxiliary space or extra data structure, the space complexity would be O of 1. So let's try to code this approach and let's see whether it gets accepted or not. So this is a code for the optimized approach we have discussed through this example, and we have tried on this approach. So here initially I have taken the size of an array in the form of variable n. I have taken the index out of place, which would be initially -1. I have iterated over the array till the size of n, and we'll check whether the out of place variable is -1 or not. If it is -1, we'll check the index element and the index value. So since it is positive, and it should be at even index, a positive element should be at even index, negative element should be at odd index. If it does not satisfy any of the condition, we'll update the out of place value to its current index. And if the out of place value is non-negative, which is not -1, and it has a particular index value, then we'll check if the current element can be swapped out into its out of place spot. So we'll check the out of place array index value and the current I value. If the out of place value is positive, the next value should be negative, and if the out of place value is negative, the next element which should be swapped with should be positive. So in this way, if any of the condition satisfies, we'll right rotate those elements, and finally we'll update the out of place index to the next position. So in this way, we'll solve this question in O of 1 space complexity. So let's try to compile and run. So let's submit. As you can see, this problem got solved successfully, and we have optimized it way further than expected time complexity and space complexity. So this is it guys for the video. I hope you like this explanation and a bonus way of solving this problem statement in our more optimized approach. So if so, please give it a like, share with your friends, and subscribe to my channel for more such coding content. Thank you, and I'll see you in the next one.